Well, there we are. Guess we're live. Let's see. Chicken and yay. That's me. Hi. Let me just post about this here. Yeah. So it was suggested before. Oh man, the echo is so distracting. Let's see. It's not echoing now. Wonder if I can get a monitor from the system. Is that working? No, that's turned off. Let's see if I can find this. Just trying to get myself a microphone monitor, but I don't think I can get this to work, so I might just forget about it. Oh well, whatever. So I found myself talking. Shouldn't be too bad. I don't even need those. Kind of the point wearing those if I can't hear anything anyway. Great. Okay, so let's get started. I need to find the Twitch dialog. There's a little chat window that just opened up when I start Twitch. I should have that sitting around on my desktop somewhere. I don't even know where that goes. OBS. It's got these. There we are. That's what I was looking for. Stream chat. Blah blah. That's good. Cool. Okay, let's get started. Sea Lion. We'll jump right back into where we were before. Let's put this over here. I'd like to be able to see. Someone cares. I'm glad you're here, Mr. First Viewer. I don't know how to get this chat box to stay on top, which is slightly annoying. I'll just make this a bit smaller so that I can see it. Or slightly lower chat. I don't know. We'll figure it out. Okay. Great. Where were we last time? Don't need that open. So I was going to refactor this. We're going to just keep going with our refactoring of changing to. Oh, I need to mention on the this other channel coding my code. So hey everybody, refactoring Twitch. I'm just going to go this to here to post link. I'm going to create a URL for this. I'm just going to say there we go. So we're refactoring the stack. Hopefully don't bore too many people to instant death. Post. See if that works. And if anyone comes along to join us, that'd be nice. And if they do, you have to tell them what's going on. Okay. Can you guys hear me okay? Anyway, so let's actually go what we're doing. Connection, network, server. We're in the sector here. We were working on servers, clients, server, run. Let's see if we can build the network stack. We want to test with the SV server build. Let's just build it on the other monitor here. I'm expecting this is going to blow up in my face because, you know, I just deliberately broke it yesterday, half doing this conversion. Okay, so look at some problems. So first thing is it can't find the crate cobalt, which isn't surprising because I've deleted that, but we want to instead create Laminar. Unresolved connection ID. We're not using connection ID now. We were using one which was in live. Where did I put that connection ID? So here I declared it in connection, and in there, what did I declare it as? A socket address. So if I was to say I wanted a connection ID, I'd have to say equal from there. Server. Use crate. It's coming from the connection module. Connection ID. Welcome to the stream. Let's see. I'm just hacking my way through a change from Cobalt to Laminar, so I'm just making changes and hoping for the best. And deliberately making a lot of breaks so that it can guide my refactoring. It's kind of break a whole bunch of stuff and fix it and then all works sort of approach. Anyway. No Cobalt client connection, no Cobalt con connection, crate connection. We remove those. In fact, this is no longer necessary. We don't need either of those. I'm not sure if we use center tools. Okay, give that to load again. Some of the module has similar problems. These are old declares I used to use all the time. And client. So giving more to the matter, client event. For some reason hasn't been declared. Oh, it's because we haven't done client yet. So we've already refactored server. To use this new client event, we probably need to go through and refactor client to do it. There are two choices here. So the first one is to copy. I'm trying to figure out if I want to copy from server or I want to copy from. I'll probably copy the one from server as opposed to copy one from this example. This is the libraries in their examples. So we'll just put in this one and client split with this. So now it's on the right, and then server, and this server is our reference because I've already refactored that. So this one here is using the new Laminar approach. This one on the right hand side is using the old approach from Cobalt. So I need to go through and replace each of these different things. So the connect event has a socket address in it. Whereas before we used to have to get it from the connection. And then the connection unwrap. No. I don't remember that being something we did anymore. I thought I changed that yesterday. So let's see what I changed yesterday just to get a better grip on what's going on. And just quickly repository and then yes, let's look at the differences. So on the server yesterday I did what? In process incoming. Server data. Should have that in. Just scroll down and continue. Yeah, that's right. Yeah, so that line there hasn't been fixed. So this con clause is actually a mistake, and so this is definitely on the other side too. And so you need to check the con isn't used again, which is not because that isn't there. Okay, so I just hit that vestigial line behind, so we need to import this. Import. A streaming game, eh? People come, people go. It's always very interesting. Well, commute. Which client commute? Okay, we don't have con anymore, so we can't use that, so we can't specify this. What we have now is that we might as well specify say which server it was, which was going to be this ID which we specifically wanted to connect to. So not really a very big surprise. Whereas with the server, you know, like when something comes in, it's a surprise to find out you have a new client. Message again is the packet. So we pull this across. Don't have a con unless like that was old handle messages. If we don't have a con, the wire passes in here. What do I do with it anyway? Okay, so I type to look up affected client using the con. Okay, so we don't even use it in here, so we can remove it from this. And in the other place it doesn't matter. But it has a con, we don't need it. So I'm just stripping out like a server client manager thing that was specified here. Yeah, this is like the most exciting thing to stream because it's just revealing a very boring way of going about solving this problem where I'm, rather than trying to fully understand what I'm doing, I'm just futzing my way through it, which is, you know, it's going to work out fine in the end, but it just doesn't look very inspiring. Oh well. Let's see. ID buffer sector. So I had this trick where I turned the data into a vector for now as a workaround for the fact that this is a different approach from how I used to do it. We go into here and remove this connection from this function. And I think I'm doing it from this one too. Yeah, doesn't use that, doesn't use one. Very good. Okay, so we're going to compile again. Underneath type, client event. So we don't have these two connection lost. We have a new one which is timeout for a particular ID. So using server event timeout. Okay. Interesting, I'm surprised it's not red here, so I can tell it to import that server event. It is red. Okay. Commas. Commas make it use things. Doesn't seem like I do. So I don't know, my system needs to have backup here. Okay, I'm going to ignore that particular problem for now and just move on to the next one. I'm sure it'll become obvious in time what the hell is going on about now. instant, reliable, ordered. Yeah, so this is how I used to send messages, which is different now. I don't know if I still want sender calls. Do I can use it anywhere? I don't think I do. I think I can just get rid of all of this because I don't need that anymore. I don't know what that's for. Okay, so we get the same problem with timeout on this side. Oh, I call it server event, but actually it should be called socket event. And I made the same mistake in both client and server. So that explains what was going on before, the one I couldn't solve. You should undo the typo module config. I don't need config anymore, so this is starting a client. So starting the server changed to look like this. Starting the client is probably very similar. Let's just quickly bring up the example what to work with, which is this one here. And in my example, I had an example client, I think. Let's see, tests, example, server client, here's a server, here's a client. That's the address we're going to open. Client. So, this new run client over here, which we're changing, we want it to open in the same manner. This is our reference in the library. This one here is my implementation. So for run client, welcome by the way. Config. So get rid of that. What's the send rate? It doesn't have anything to do with this. For initializing socket. So we're going to open the socket in a similar way as we do here. So here we just pardon on that. Interesting. Okay. So with this one, you bind again to address, which is going to be the remote address. So that's, yeah, so we're binding to the local address. Yeah. Interesting. But I create a new Cobalt client here. Yeah, so in this case, they're modeling full UDP. So they've got even the client is actually binding to the local socket. And then down here, it's specifying the server it wants to send to. So the client can essentially do peer-to-peer, can do multiple, whereas Cobalt was making a pseudo TCP/IP connection. So you didn't need to bind to you didn't need to specify the local port. So for this, we're going to have to actually create a bind to a local port, which is going to be, we'll just try 127.0.0.1, and we'll specify 0, I think, which will tell the operating system to find us a port, as far as I understand. Double quotes. Once we've got a socket, one of these sockets tell us what the port is. Connection manager. Interesting. I don't know if we can find out what port we got. Is that even relevant? And it probably doesn't matter. It would just be for diagnostics anyway. So Hmm. It just struck me that I'm viewing my own stream, so I think what's going on is that the one viewer I can see is probably myself. I'm watching my own stream, so I'm streaming to myself. That explains a lot, actually. Makes a lot of sense. Interesting. Anyway, initially I thought I wouldn't count myself in that list, that count of how many people are watching, but oh well. Great. That's a good feeling. Streaming to yourself is always fun. Mankind. I'll put the window in. I wonder how much you can hear that road noise. Oh well, I'm sure it'll be fun. Bit of fresh, you never had anyone. So, client, mosquitoes will eventually hit someone. I'm just stuck in the train of thought at the moment. Okay, run client. Create a new client. It's got to have a UDP socket. I'm hoping port 0 means the operating system is going to give me a 1. In my example client here, whenever we send, we need to specify the port of the server. Here we get the sender process incoming, send outgoing. When we're sending, we're going to need to know the port of the server constantly because of the way this works, which is going to be a bit of a nuisance. So how are we going to track that internally while sending? Because in this example for packets, we've got to always know, which means we're going to have to pass something in that can hold these kind of flummoxed by that because I was kind of expecting that I wouldn't have to track the server port, send outgoing. Which probably also means the server needs to know the port, but I'm surprised I didn't run into a problem with that when I was compiling or thinking about it earlier, creating this packet. I don't know if I even went so far as to write the code to send the packet, which is probably why I didn't notice. Packet, timeout, send outgoing, populate sender. So this is where we actually populate and send a bunch of stuff. Yeah, so I was using this class I called sender queue, and I just commented that out. So we're going to go back to sender queue. We're going to bring it back to life because I think we're going to need that in order to make this work. So we call that sender tools. Where's sender? Sender queue. This is a vector of the message kind, and messages. Messages are the type of message we want. So these are all the different messages that you can send from inside the game. So I define these. So my code as it stands returns a vector of everything I want to send called outgoing. Okay. What does it do? It's calling connection and telling it to send all of them. And I think send all just happens to be defined the way I want. But what I could do is, instead of calling this send outgoing, it could be collect outgoing or something similar, and then it could be handled outside. That's what we're going to do as well. We'll collect outgoing to who? To this client. So in this loop, we actually know the IP addresses of the people we're trying to talk to, because in client lookup we've got a hash map that connects connection ID, which is actually an address. So we can make that work. We've got a vector of things to send, which is outgoing, a sender queue, which is defined here. So we'll put that over here. So in server, send outgoing. Okay, so once we know what this is going to be, so we know that outgoing is containing all these messages. It's filled up with stuff here. So here we need a new implementation to send it, because in the past I had this implementation I wrote into Cobalt myself, which just sent anything serializable. So there was a way of asking things which are serializable to serialize themselves. So let's just quickly look at the source code. We'll open a new window and we'll look at the source code that I wrote for this before. Open, and have a look at Cobalt. So my Cobalt source is in lib Cobalt. There's new window. And so this the source. I'll just be missing more stuff here. Interesting. Source. I don't know why I can't see everything in this list. Open. Yeah, that should be the correct one. There's probably something here. Project source files. Project files. We'll just use this. Okay, source. And the one we want, we're going to find send all. And see how I implemented that before. No? Word? No? Interesting. Can't find it. I'm getting very confused now. Connection. Okay, what we'll do is we'll just look at an old version of my repository. So we'll grab C drive, game dev, Star Factory. Got an alternate one here probably. Base Factory old, that's too old, I imagine. Let's have a look at its versioning. Wow, that's really old. I must have been playing with this to generate old screenshots or something to see, say, what I'd made in the past. So what I'm going to do is I'm going to update to a commit before I started refactoring, and then I can use that commit as a place to open my source code repository, and then I can investigate how things used to work, and then that will give me some quick clues as a shortcut. Interesting, that's quite an old commit. I probably didn't push them out of the way. They'll give me some quick clues as a shortcut. Just give me something to copy because I can't bother with you out of you. They won't let me check out because I've done some changes. I don't mind losing all of this. I need to do that. Reset all these changes. Reset those. Reset those. Reset. Good. Whatever. Now. Check out each branch. There we go. Right, so that checkout's going well. So we're going to open a new version of C-Lion, and we're going to point it at that folder that we're just checking out at the moment. So that was the game dev, and it was Space Factory Alt, I believe, that I'm just checking it now. Yep. So new window. So in Space Factory Alt, let's have a quick look at what we've got here. This is the entire source repository. I should be able to look for that file, that symbol, which is send or in connection. There we go. Drain engine queue given sender queue. So that was actually the code that I was looking at in connection earlier. Great, okay, cool. We're making some progress. Okay. What if that means I can save something in the tray? I don't think it does. So what I want to do in this case is I want the send all function, which is in this thing called connection. A connection isn't that, it's actually UDP sender packet. So if we have a sender packet, we want to be able to call send all and then queue these messages. So I need to go back to connection, which I had before. I'm in the right place there. Right, so now I remember how this works. So I declared a trait sender tools. Yeah, sounds also got some effects on it. Let me just change the filters. I've got noise suppression and a compressor on, and it might be that the suppression level here is just set too high, and it might be that we just want to turn those off. I don't know. How's that now? Close. Did that fix the problems, Mr. Weird? Anyway, if that doesn't... Yeah, there's something that's causing a lot of noise on the pickup. I wonder if I need... I could also move the microphone closer if necessary, but it's probably the effects that are causing me a problem. How about we just see how that goes? Yeah, I could put the compression back on. This is change the compression to turn that on, compressor. So this makes the volume consistent. So we'll turn this on, and I'm not sure if what you should find is that it brings my voice up to an equal level. So, you know, we'll see how this goes. And if you don't like the compression, I probably need to play with it. Anyway, we're getting distracted by noise and microphone settings. How about I just turn that off for now until we're happy with it? Or unless you say, oh yeah, the compressor was way better. And then I'll put it back on. Oh, compressor's good. Yay, we'll leave that on. Good. Thank you very much for your feedback, Mr. Weird Constructor. I probably should have recorded something and then like played it back and had a look, and I've had real trouble getting a loop back on my microphone going. That's why I'm not wearing any headphones. Okay. I was going to, so what we're doing here is we're creating a trait. So the trait in Rust, sender tools, which declares a function send all, and then for any, because we declared this trait, we can then pull in types that are declared in other places, and we can add this method send all to them. So we're going to add a method send all to anything that is a sender of packets, which is what we're going to get with this new library. So if I have a sender of packets, it's going to have a send all function. The send all function is going to be passed in a mute self, which is a sender of packets, which is good because that's what we're going to have over here. So then that means that UDP is going to get this method called send all I can call and pass it the outgoing array. So this packet import, so that's the Laminar packet, and so what we need to do for each of these is we need to drain a queue that's been populated by the game code, instantly choose which kind it is, one of these three kinds. So these message kinds need to be changed into Laminar kinds, and we need to serialize the message. This serialize function will be the one from bin code. So bin code is like a Serde serialize, deserialize packet thing. It's turning a class into data because they derive from serializable. So the way this works is kind of neat. We'll just go through this real quick. Sender queue is a vector. That vector is tuples. Those tuples are message kinds, instant, reliable, or ordered, of class message. Messages can be one of these. These are all the messages I've got in the game. The most important message is action submit, which is this one. So, which one do we want to do? That's it being used. I was expecting to find, I need to probably go this one, which is a structure like so, contains a world ID, an action counter, and an action. Let's see what an action is. So action at the moment could be place a module, remove a module, or adjust the floor. And one thing I've been adding is we're going to have an action as well, which is going to be, where are we? Connection, client. No, that's probably not what I meant. No, that is the one I meant. Connection, client, tile. Odd. This is not what I expected to see. Oh, it's because I was looking at the wrong thing. Diff. In actions, we add a new two actions, player input and interact with. So these are going to let me have players move. So if we have a look in player input, I've started declaring what that actually means. Front, back, left, right, that sort of thing. So this is going to happen later, but I realized that if I'm going to start having the game filling in this data structure every like multiple times a frame, I wanted it to be really, really easy for it to create actions and put them in the network stack, and it started to become really clear that actually my connection between Godot and my game code was a bit tenuous. It didn't really matter when I was only passing in things every now and again with actions, like when you click on stuff, but if it's happening multiple times a frame, it's going to cause performance issues and also ship synchronization. It was getting a bit ridiculous how hard I was working to keep my world synchronized, which is why I'm doing this refactor in the first place. Anyway, so actions are sent over the network, and they're sent because we derive serialize and deserialize, which are from Serde. I believe I use a serialize and deserialize library of some kind to make that easier. And it puts them on the wire and it nests them really nicely. There's this module called bin code. Yes, so we are going to invoke the serialize functionality in order to do this, which is done by causing serialize message, which returns either OK with a buffer or error. And if it calls OK with a buffer, we have something we want to enqueue. What we want to do is put it in the sender queue here. And so if we have a look at the sender queue, what the queue is actually an event queue where we can push stuff in it here. And the values we're going to push are packets. So we're going to create new packets. And if we ask cline, it's going to tell us what the missing fields are. So we need all these fields here. So if we push all those things, we're going to get a 1. So in this case, we pass kind and buffer. So for buffer, that goes in payload. What kind is a buffer? It's a vec u8. So we just need to ask it for a slice reference or something similar. What is payload? It's a box. So I bet if we had a look at the vector documentation, let me just whip that up real quick. But
if I have a look at the vector documentation, I can very quickly find out how to turn it into a box. So let's have a look. All these classes. Oh, into box slice. That looks, well, there you go. I mean, like, how awesome is that? So it's exactly what we're looking for, into box slice here. So we'll just call this puppy and we'll be able to turn this into what we're looking for here. So this payload requires a box slice. So we just say buffer dot into box slice, and that's the buffer sorted for the address. We might just change the send all signature so we pass the address in, because that would solve that problem. So if we have a look at this address, hold down control, we can see it's a socket address. So we're going to say send all requires a socket address. And then we just put this in the packet. Like so, and we add it to the trait as well. So we say that if you're implementing sender tools, you need to also take an address, like so. Payload is buffer into box slice. Delivery guarantee is going to be the one from the message. So SG kind, we need one of these kinds. So we're just going to have a look at this delivery guarantee. This delivery guarantee class has unreliable or reliable. Okay, so there was the other one. Okay, and connection. So I've got instant, reliable, and ordered. I believe instant meant I don't care if it gets thrown away. Yep, send exactly one sitting ordered in case it's lost. Reliable and ordered. So those are the three I care about. And so in this library it breaks them into two kinds. So it's either ordered, and this one here we are, ordering guarantee. So we have sequenced, or we have and we have ordered. And you can also specify a sequence number if you want to. At the moment I'm not going to, but later on it's going to be really useful to do that. Let's not worry about it for now. So we're going to say we want the guarantee. So what do they call down here? They call them delivery. Okay, so the first one is delivery and the second one is ordering. And so based on this kind that I define in my game code, I'm going to want to have a tuple, and at first, if it's instant, then I'm going to want the ordering guarantee of none, and I'm going to want to have the delivery guarantee of none as well. Ordering none. Well, that's pretty straightforward. Okay, for reliable, we're going to want both guarantees basically. So ordering guarantee needs to be sequenced. I believe that's what I care about. I can't remember if for reliable I wanted it to be sequenced or not. We'll just put that in there. And delivery guarantee, reliable. And so that's basically TCP/IP. So anything that's of that type is going to be reliably sent like TCP/IP. But in the middle of a stream containing other data, so you know it's more efficiently packing packets, which is kind of the point. Well, at least I hope it is. I mean, what put me off this library initially was the fact that when I looked through, there were some qualities I didn't like. I think it didn't pack everything into one big packet. It broke things into lots of small packets, and I was like, well, it'd be nice if you guys collected to get everything I sent at once, somehow. But hey, I mean, you know, they're just trying to make my life easier. It's okay. Sequenced. So this is actually takes something. So I need to put a none in here to say I don't care which sequence it's in. Reliable. I don't think that matters. No, it doesn't need a stream. Same here. None. So for ordered, I need a sequence, but I do not care if it's reliable. It's actually okay for that to be unreliable. And so this is useful for input actions perhaps where we have a lot of redundancy in the packets, and if it doesn't get through, we actually don't care. We just, the next input is going to solve us. But for now we're going to send actions as fully reliable, and I'll fall back to the unreliable later when I care more about latency. For development, it's okay for things to be a bit slow, and we can just handle that as a special kind of a special case, but just need a plan for it so we know it's possible to solve sometime. Okay. serialize. We have our address. We have our payload. Our delivery, well, we can just do this because it's Rust, just say delivery and say ordering, and because our variable names up above match the fields of the struct, that's fine. We get rid of this extra code that I had there for some reason, and I think I need a comma here. And then that's our implementation. I don't know why it's not happy with this delivery and ordering. I've put them in the wrong sequence. Interesting. Or, oh, I see what I've done. I specified delivery and ordering here in the sequence. So I've put my ordering in the variable called delivery and my delivery in the variable called ordering. And if I look at the hover, it would have been really obvious, but you know, I wasn't paying enough attention, so I didn't notice. Okay, so this should now be happy. Okay, so we expected an SG message kind and a message, and we found a packet, which isn't very surprising because, well, match 4 and Q drain, send all, Q push. What do we expect to push into this? A value T. Okay, what's our problem? I'll send a Q here is wrong. Q push send a Q. Where's send a Q from? Yeah, it's not Q we're pushing into. We need to push into self. That's the problem. Self dot push. Is it push? It's like in Q or send or something. Yeah, send. Great. So self dot send this. Now I noticed there a send all. Wonder if send all is more performant than no, there's no send all. Thought I saw one. Or no, okay, I was mistaken. Well, that's good because I won't get distracted by trying to improve performance before I even have a problem, which is always good. So, in summary, we had a sender packet for this new library Laminar. We created a trait. Well, I reused a trait that I created for Cobalt in the past. We have a trait here called sender tools. It says that if you implement this trait, you should implement send all and take it in something called a sender queue, which is populated inside my game logic. So my game logic doesn't know about networking, which is why it populates a sender queue, which is just here. It's just a vector of messages, this function here. If you have something called a sender packet, then you'll kind of find it implements a trait called sender tools, and suddenly you've got a function called send all, and in that function we're going to go through all the messages that are in this game specific queue, and we're going to map my internal names, instant, reliable and ordered, into the ones the library expects, and then we're going to fill this buffer here, self, with the packets. So we're going to send them over the network. So this is my abstraction. That means that my game logic doesn't need to understand how the network code works. So now we can go back to server. Now server, man, I'm sorry about all those burps, guys. Put me on stream and oh, it's so embarrassing. Anyway, center tools. I was expecting to find that when I went down this page, that I was going to be using the sender tools class. But I think that's right. These functions don't say. It's one of those things where we just call send all, and this will go red if I don't include sender tools. It will not know about the trait, so it will not be able to call this function. So this line will just not work. But here we've declared we're using a sender packet, so this means the send all function you just saw me writing is going to get called when I call that, which is really cool. So because I've forgotten what the next two do is, I'm going to just compile it, and it's going to tell me because things won't compile. Because I'm halfway through refactoring, and I'm using the method where I just deliberately break the code and then fix it, and the fixing will actually do the refactoring for me. Okay, which is great when I can't be bothered understanding all of my own code at the same time. So, run client. I was in the middle of refactoring how run client started, and the problem I was trying to solve was that I need to remember what address we're trying to talk to, because my old client implementation remembered the address in the connection, and the new one does not. The new one allows me to talk basically peer-to-peer, which is in theory really nice, but in reality it's just a bit of an extra chore because I don't need peer-to-peer communication for my clients yet. If we had well, the advantage is the client's going to be able to talk to multiple servers over the same object. Is that good? I don't know. But I don't want peer-to-peer between clients because that reveals people's IP address to each other and it causes firewall issues, and it's just generally not a very kind thing to do in the face of a hostile internet to our users. So they're only going to know about the IP address of clients, of the servers. So we're going to go to run client. So in our example for this library, connection, in our example of this library, which was not this one, we had another one open in the background, what it does is it opens a static IP address, which is, that's localhost and a static port. I don't really know if I want to have a static port on the client. Do I care? Let's just say I don't care about having a static port on the client, because if I do, it's like you can't run two clients at once. But I want to do that for testing. Okay, so we'll leave it at 0. I'm going to trust that the operating system is going to figure that out. If it doesn't, we'll find out soon enough. And then further down, let's see, connecting, failed to bind to socket, client new, sector, build test starships, set master. This here is only there because I don't have a full sync. Whereas later on, when I have a full sync, I won't want to have the client create a global state like that. Well, the client is live. So this client live acquire is about creating a flag. That means that we can have a thread. Client live is actually a static variable, and I believe this is because run clients invoked inside a thread, so I wanted a loop that would exit when the static variable was set false. So client live is actually a atomic boolean, like so. So anyway, so while the atomic boolean is still true, we're going to sit in this loop, get the sector, process the incoming, do a tick, send the outgoing, and between these loops we release the sector by going outside of these curly braces so that it can be picked up by the go.thread thread. So this is how our network thread currently works. I'm probably going to turn this around later on and make it so that the go.thread thread runs the client in its own thread and pulls it deliberately itself on a constant tick. We'll see how that goes later. So in here we want to get the sector, process incoming, with the sector, we pass in the socket, so that's what UDP is. We pass in the sector. We're going to need to pass in as well the client ID. Packets that are coming in already have the IDs in them that they came from. So we probably should do something in this that's going to check on the client side that it's actually the server talking. That would make sense. I don't know if I actually do that already. Handle messages. Yeah, it just trusts that anybody who sends packets to it is the server, even if the packets are labeled as coming from someone else. I think part of the reason why is because I had there was a communications protection already built in. So we're going to have to do something to remember what the server address is in order to do something really naive initially. That'll probably be good enough. Okay, so for process incoming, we're going to have to modify the definition of what process incoming does. It's going to need to take a server address. Yeah, it's going to be fun to figure this stuff out over the long term, because I haven't looked at my networking code. I haven't looked at my networking code for months and months. This is why I'm taking so long. And so I've kind of forgotten some of the details here. So I know why I'm switched to all the. I've broken that first one down to the first line. Okay, so that's a socket address. Okay, so with these addresses, import that. Import the receiver address. Import the receiver class. I want the crossbeam one. because this is sending from a network channel back to us. Socket address. Yes. Okay, so we're going to get messages, and what I'm going to do is I'm interested in client connected. It says client connected to server, but that makes no sense. Oh, yeah. Well, it says ID here. Interesting. We'll put an if statement here first. So if ID is equal to the one we expect server address, we're going to say it connected. If otherwise, we're going to say there was a problem, unexpected. I probably need to write some code at some point that specifies, like, that tests that this actually works. So as you can see, client received unexpected connection from, and the ID of who tried to connect to us. And we're going to have to do something similar in every one of these branches. We don't have a connection here anymore. Packet, import that, buffx, so we need to check that it's the one we expect. My else didn't come out quite right. Let's try it again. It's kind of by my mind right now that there are 10 people watching me. It's like, oh my god. I'm glad you guys like watching me code. It's kind of cool. Nice to have you along. Thank you. Feel free to say anything, ask questions and so on, or ask each other questions, or join my Discord. In fact, I probably should put a Discord, share a Discord link real quick, just in case you guys want to hang around afterwards. So let me just make a quick Discord invite people, and we shall give you a very special one that expires never. And you shall invite all your friends. Hidden. Use the copy button. But it's too bad. It's already on the screen. It's in the chat. Feel free to jump over there if you like. And come back and I'll post in there if I ever do stream again. And otherwise you can talk to each other. It'll be very nice. Or not. I don't mind. No pressure. So, process incoming. This now takes an address. Remember, I just changed that, so it did. And the address we want is in a constant called server, right? Do tick. This part here is my game logic. It's just making everything move around on the server or the client. This one here is the address again, but we haven't put that part in. And it's interesting how this has gone red. I probably need to pass it as a reference. Okay, so server is in the socket address. Okay, so how do I create a socket address? It's an IPv4. Let's go to the documentation. So, that's that. I don't know why I'm getting notifications from Twitch, but I'm sure that they can wait until later. Where are we? Oh yes, I'm in the right place. Great. Okay, we're going to have a look at socket address, which is in here. Oh, we wanted the v4 one. v4. And we want to find out if we can make one from string. From string. Okay, great. So, we can just, well, from it, which is magic. So we just go, we just use into. So if you don't know how that works, it's because there's a trait implementation to do with from that I just found in the documentation, implemented from string for socket address v4, and or more importantly the one that's right below it, which is called from. If you implement from, it's probably, well, from string is probably a trait of from. Anyway, if you implement from, you also implement into, and if you implement into, you can just use this function called into, and it's wonderful magic. Totally worth doing, but you have to still explicitly use it, which is good because you don't get magic. You don't want magic, you want to be really clear with things. And so I have to use it into, I can't just expect it to change magically. Yeah, async and await. I haven't, they look really exciting. I haven't explored those yet, to be honest. I'm very much a guy who just tries to stick to what I know and only go outside. There's so many new things to learn. I can't learn too much at once, but it looks really exciting. If I was talking to a database here, it would be so wonderful. I don't think it really makes sense for this though, because we're going many to many. These kind of connections don't really, I don't know if they'd suit the idea of one function that's like acting like an async thing. We could probably make agents or something similar that would make this code simpler. I understand the old school way of doing it. I hadn't even thought about using async for this. Yeah. I've been on Nightly quite a lot recently. I only really went to stable because there was a bug in C-line to do with Nightly. But there's some really nice stuff in there, like option XOR. I really like that. So that was a good reason to go to Nightly for a while. There's some debugging in specs because of it. Okay, send outgoing. So we're just halfway through changing process incoming. So it uses a server address and validates that we really are talking to the server, and we're not a client receiving a message from a different client and treating it like a message from the server, because that would be bad. So we're going to put a debugging thing here that says client received message, unexpected message. And to be fair, if I leave this in the code, this is going to allow you to denial of service somebody, because writing to console is really slow. So I probably need to remove it later. But I put it in here for now. So it's a packet. We've just decoded the packet very helpfully here. So what we'll do is we'll grab the payload and do nothing with it. Yeah. We'll just put the payload here, and I'm sure it'll output it correctly. What could possibly go wrong with that? Nothing. Nothing at all could possibly go wrong with that. Okay, so nothing. I beg you, nothing. Anyway, handle. Why isn't it not happy? Oh, because I removed this argument called con. Okay. Timeout. ID. So we only lost the connection if it was actually the server one. So we're going to put this test in here one more time. We no longer have this object called con, so we can't put that in there. But what we can do is we can specify what ID disconnected. ID. Okay, so that's the client. I think we're almost done with this client.rs file, apart from that failure, and that failure, and that failure, and that one, and this one, and this one, and those ones. Yeah, I like the debug macro too. I almost always want to write something custom, almost always, and so I haven't actually had a chance where I wanted to use it. I think there was also some other reason why. No, as soon as I found out about it, I immediately went to edition 2018 and thought, yes, the debug macro. I'm going to use that. Haven't used it yet. Oh well. Anyway, I did too many programming competitions and just got too comfortable with string formatting. This is not how you do a programming competition, by the way. Trust me. Anyway, let's see. It's way too slow. I'm being way too slow for a programming competition. Man, that's so far in my past now. Okay. Lib. Use of undeclared type. Cobalt client. New. Config. We don't want that. UDP. Socket bind. Here. As we go down, we need to unpack the sender and receiver. So, in this one, we create a socket, and then the socket creates a thread, and then that thread creates a sender and receiver. This connect is old. How do we do the connect now? When we bind to a socket, we don't actually connect explicitly. We just send messages. So I'm going to get rid of this. In fact, we might end up having to specifically send a hello message of some kind. I'm glad you like my crazy humor, Mr. Weird. Let's see. No, I've lost my train of thought now. Nice one, Tom. Client. Server. Client. Type of message and press enter to send. Standard in. S buffer, clear the buffer, read the line, and then send here. Okay, so, you know, it's a stateless connection. If we're going to do this properly, we'd probably go back to what I originally did when I first started implementing my own network code, which is I very deliberately sent a hello and a reply and who's there and a reply, and proved that it actually was a proper connection all the way through and shared an ID and all that stuff. And when I changed to Cobalt, I didn't need that anymore, so I stripped it out. I'm probably going to go back and put it back in to make this reliable again. I don't particularly want to do it right now, because I'm just really too lazy. Yeah, but I'm going to have to put that in eventually, otherwise people are going to be able to interfere with each other's connections, and it's just not going to work very well. Because you can send a message to the server pretending to be from someone else's IP address, and then the server replies to where you sent the message from, and bad things happen. Especially if you can end up with an amplification attack type situation where the server sends back more than you sent to it. People will use your server to do bad stuff. Okay, run client, load acquire, get the sector, UDP sector, server into. I do believe we're pretty much there. I don't think I need to. I don't need that send anymore. I think it magically does that, and that's one problem we're going to have with this approach. This is something that I remember it all now. Like, it's all coming back to me how I used to use Laminar, and I had this whole different design for this whole folder. Let's have a look at what I used to do. This old me that knew what the fuck was going on. Oh, pardon me. Toy paths, run, paste, source, and we're looking at lib.rs and get extensions. We're going to look at the file history of lib.rs. Let's have a look at what has happened to it. So when I first started, this first code here, it's already using Cobalt. So I think you'll probably find that if I was to look through my history of using this code. Okay, so let's jump back from this file to the toml file, which they named after me because, you know, that's what you do. I'm Tom Lees, for anyone who doesn't know. Anyway, toml is file history. I'm really surprised it's got such a short history. I was not expecting a short history on that one. Oh, it's because I got the workspace one. Oh, of course. No, this one. Get extensions, file history. That's something more like I was expecting. Okay, so in the depths of time, I'm just trying to find the point here where I added. I expect that I would have added to net. Because I'm in the right one? No, I'm in the simulation one. I don't want the simulation one. I want the net one. Okay. Interesting. Good extensions when I ask it for the file history of the net one. It's giving me the net one now. Okay, that's good. No, if you look at this, it's giving me the patch for the SG core one. SG core. That's still SG core. That's the server, simulation. Yes, it's filtering on the name of the file. It's not filtering on the folder. I want the net one. There we go. That specs is being changed, so we're using Cobalt for that version. So it probably predates when I restructured where all the folders were, which is annoying. So remember this alt one that I had back here? And okay, I'm not sure what it's doing now. Abort. Abort, etc. It's like a frog. So serialization of entire ships. Client and server now exchange challenge messages. So this is probably back when I used to use the other kind of, probably this is when I was using ES. So see, this is my old code that used to use Laminar. Wow, have I gone down a complete blind alley here and I should have just used my old code again. Well, we're going to try that approach and see how that goes. That should be good fun. So that's the 3rd of May this year. This is locking up if you hadn't noticed. Yay! PC problems. Nope, it came back. Good, okay. Move the concept of a server sector into its own module. The test client server now refactored around sector. Unreliable packets for the connection process. Serialization of entire ships. So, here we go. So, on the 15th of May, I made the brilliant decision to replace Laminar with Cobalt. And all I've been doing so far for the last hour is reversing that decision. And wouldn't it be so much easier if I just could use the version that I had before, or that I never made the mistake of changing across in the first place? Yay, software development. Okay, so what we're going to do is we'll create a new tag here, and we'll call this one Laminar, the good old past. I'm playing it up because I'm on stream. I'll probably just call it like TM1 otherwise. Anyway, check that out. You guys make this a lot more fun. It involves a lot less watching videos and getting distracted when I'm actually on stream, and I feel like I need to pay attention to what I'm doing. So, check out this commit. So, in case you hadn't noticed, we're in this folder called Space Factory Alt. What you see me in the background here, all the code I've been editing, that's actually in a different repository. That's in Star Factory. So Space Factory is what I used to call this before I renamed it Star Factory. The actual name's the Recall Singularity now, but my code is still called Space Factory or Star Factory. So I've got two folders. Well, I've got multiple folders, but at the moment we're working with two of them checked out. I'm just going to make a little commit here of my broken code, just so I've got something to work with. So we'll just stage everything I've done since I started doing this stream, and probably last night as well. Man, it's going really slow. Interesting. Must have made some changes in Cobalt as well. Let's have a look and see what I did there. It should be opening a submodule in a second. Interesting. It's not managing to do that. Oh well, I'm sure that everything is fine. Whip. Hacking up some terrible change over to Laminar. Okay. So what I'm thinking is that if I was to go back to my old version, I'm going to have these nice features that I coded in because I was using Laminar rather than Cobalt, like a challenge and response and that sort of thing. I don't know why my C drive's going so incredibly slow. There's probably something funny going on. And not in the sense of like, haha, that's funny, but more in the sense like, oh shit. Pardon my French again. I probably should be more careful on stream. Oh no, I've got plenty of space, I'm okay. But something is going slow. It may be because I'm running so many copies of this, or maybe because of one of my many browser windows open. It's waiting for a commit message, I think. Interesting. Oh well, I'm just going to leave that to run. The main point of what I was doing before, so this Space Factory Alt. Okay, so they're both locked up now. Okay, this one's done. Okay, this one's still going. Now that one taking some time as expected, but it's not expected to lock up. I wonder if I need to look at Process Explorer and find out why my computer's going so slow. Let's just quickly do that because it's getting a bit annoying. I need to check out this other version, because then I can start a comparison. I can look at what the difference is between my source code then and my source code now, and then I should be able to copy things across, which should save a lot of time, actually. Hey, Adwani! Nice to see you. Don't worry, you didn't miss too much. Nothing super exciting, just a bunch of refactoring. I don't know why Process Exploring isn't launching. Okay, let's try Task Manager. Hopefully it doesn't interrupt the stream. If you can still see anything, I'm just bringing up Task Manager and it's taking a long time. Okay, so Task Manager can't see any CPU problems. It says I've got 35% of CPU. So one of my CPUs is pinned, but it won't show me which process is using all that processing power. So Process Explorer is here. Nothing too exciting. Although Git seems to be starting a lot of processes here. I just think that this is just spinning up tons of processes somehow. So we're just going to quit out of space of this browser. So that close some of them. So let's take a okay, so the topic we're working on right now is we're trying to replace one networking stack with a different one, and generally just look through the networking of my game. Yeah, watching a guy code, I love it. That's a good topic. What you're watching right now is a guy struggling with a computer that's just gone haywire, and it's just running 1,000 copies of Git for some reason. I might just be very explicit and just kill them all like this. So we'll sort them by name. Okay. So that would not be a good way to run a computer. Can you see how many Gits are running here? So kill you. Kill you. Kill you. I kill you. I kill you. I kill you. I kill you. This is incredibly boring for you guys, sorry. So something about checking out that repository has caused it to start up 1,000 instances of Git. And what's going to happen is, of course, I'll delete all of them, and then it's going to all happen again. Almost there. There we go. This is your 1 minute interlude. It's like Space Fighter or something. Oh, that was great. They all went away. I must have found the process that started it all somehow. And let's just hopefully not create this problem a second time. I'm going to watch it over here like a hawk, and I'm going to just quickly try to do this again. So I got very suspicious about this process before. So the commit we're looking for is around May the 15th, when I decided to replace everything with Cobalt. That one there. So oh yes, Laminar, the good old past. Oh. Okay, so it's now starting up 1,000 Gits. This is really not good. It's very annoying. So that's a commit hash I want. Something funny is happening with that program. And they've all gone now. Are they dying? Yeah, they seem to kill themselves, which is good. That's weird hope. Anyway, it was the last time you had to do that. I expect. Let's try the other way of doing it. Okay, so we're going to open a command prompt. We're going to go to the folder in question, game dev, skill space factory alt, good, and we want that hash. This is when actual Git has the same problem as the Git UI. I think what we're waiting for is that every single one of these Gits is locked the repository, and so I can see them closing themselves down one at a time. There we are. Finally the console is allowed to go. Interesting. So it seemed like some problem in Git extensions because it's spin up lots of copies of Git that each one reserved the repository for too long, maybe took too long to respond, and so it spun up another one while it was waiting. Wonderful. We got around the problem. So, in rs, in lib, inside of, wow, this is the old layout. Where did I put my code? I think I put it in sg, rs, lib, no, okay. SG core, this is my old, how I used to do things. Server, simulation. So, the log, I'm just trying to figure out where my source code is now. I'll probably put it in server, source, connection, client. Wow. So this is before I must have, what I must have done is, this really is the mist of time. I must have split the server into net later on. So let's take this source code and set it as the left side for compare. Okay, this is the old version that if I got this right, or I'll go into this one. If I got this right, set as left folder, is going to be the one that's still using Laminar, and we're going to go to the right one, which is right in the sense of being on the right hand side of the screen. The one we're going to put on the right is going to be the new code that has not the functionality I want. What crate am I using for my UDP server? Okay, so I started off using Laminar. I refactored to Cobalt because I liked the Cobalt library better, and then I realized that I probably should stick with the library just recently that's in its own thread, and that has maintained some getting back to Laminar. And I realized because I used to be using the Laminar crate, I can save myself a bunch of work by reusing the code I wrote back in May to manage the Laminar crate rather than doing it again, because I added some extra code to manage the idiosyncrasies with the library. rs is in the light, it's in sg. We're going to look into the server folder. We're going to compare the server folder. So we're going to compare the one that's on the right there. Other right. We're going to compare the one that's on that right with my right to that one. Good fun. The streaming business. Select left folder. No, that's not what I wanted. Select left folder here. And then here I say compare to SG server, and I get beyond compares folder comparison. And if I go into here, we should see very similar source code, not at all. I probably need to compare this one as the left folder. Select as left folder, and I need to compare it to net. That's what I want to compare it to. Okay, because in my new code I put all the interesting things that talk to the server in a zone repository called net. The SG server is just a wrapper that invokes it. It doesn't have any logic of its own. So let's have a look at what my connection used to be. And the nice trait of this diff is that anything I put across into connection becomes. So I'm just going to. This is when I do it before I start mucking around with my source code. I'm just going to quickly check that I have committed. I like to know that there's no files. Yes, there's no outstanding files. That if I break them, I messed up changes I haven't saved. Essentially, I've saved all my changes so far by putting them in Git. So, well, look, I used to use this thread, socket address, debug. Okay, channel, crossbeam channel, receiver and sender. Yes, that's not surprising. Laminar types, a UDP wrapper. Represents a UDP socket wrapped by Laminar and wrapped again by us. So I had send one reliable and send one unreliable. Oh, it's all coming back to me now. This UDP wrapper contained the packet sender that we had. And it had the receiver as well. And I put the thread in it. Okay, that's interesting. And so you could just send things by using send one unreliable. Okay, that's interesting. So I'm not sure if I still want to reuse that approach. I quite like this other approach I'm using where I'm not writing my own wrappers for every little thing. So we'll just leave that one alone for now. Let's have a look at the server. So what did I do last time? Cross-beam channel. So I had try receive error, Laminar, network. Okay, cross-beam channel. I had this thing called tickable, which I thought was quite neat, and that handled the server tick speed. It put the server to sleep between ticks. It managed keeping it at a standard steady tick rate, that sort of thing. So we're going to restore tickable, and where was tickable from? Was from the crate, so that means it's in lib. Why can't I see a lib here? Oh, it's in main. That's why. So compared to that one, I should have said align with, shouldn't I? And this trait tickable, spawn servers. Ah, that's right. So I made each of the server and stuff tickable. Do tick. Spawn server. Tick thread. Yeah. So tick thread was a bit of logic that I put in, which would call something that was a tickable at a reliable tick rate. So I'm just going to Control C, copy that, and I'm going to place it up here above run server. So I'm copying it from my old code and I'm placing it into my new code. And I'm also going to copy the trait that it implements here. This here. So if you implement tickable for something, your tickable needs to implement something called do tick, and then tickable is going to ensure it gets called sorry, Aldewan. I'm very much a novice streamer, and after spending an hour trying to get everything up and running, I finally started as soon as I could. I'm kind of glad I didn't say I was going to start at 8 PM New Zealand time, because if I had, it would have been disappointing since I actually started at 9 PM New Zealand time. So I'm sorry, them's the breaks and so on. I'll do my best. I hope you enjoy what you do get to watch. Considering just watching me struggle, unless you enjoy watching people struggle, the less you watch, the less you enjoy watching me struggle. Anyway, let's continue copying code from our wise past to our flawed future. So wise past is on the left, flawed future is on the right. What other goodies can we copy across? This chrono thing sounds cool, but I think it was just a really accurate clock. Tick thread, main, server. Yeah, so this, I don't think this server stuff is anything to write home about. So I'm going to leave that as is. So I think we can say main and lib are done for now. So if we go back to connection and compare those again. So yes, I'm not sure if it's a code that's developing or myself. I think it's both. And this streaming is actually helping quite a lot, because I've been kind of struggling at the lately to keep applying myself to the code and just keep banging my head on this wall of development, and having a few people cheer me on is making a difference. So that's nice. So thank you for watching. Just having you watching is keeping me honest, so I appreciate it. Oh, there's a yesterday's stream on YouTube. If you want to see a demo of what this can do already, let me just quickly grab the YouTube link and put it up there, so that next time you feel bored and you wish that I was online, yeah, if that ever happens, you can have a demo of my channel. I'm going to put it in the chat in a second. That's deliberately small. So here's me talking. You probably can hear that. Here's me talking yesterday. So I want you to watch that as your homework, and if you watch it, you'll see there's a demo in there of the game that I'm working on right now. Even a multiplayer demo, you can see it working in multiplayer. There's two clients running. You can see them saying sync and stuff, so on. So all that stuff's in our Git history now. I thought I could hear the video still playing. Anyway, all that stuff's in our Git history now. We're looking to the future, and we've completely broken the networking by changing it. And we're going to forget that we can just check out the old version and pretend that this whole mistake never happened. So, debug, UDP wrapper. I don't want this wrapper, that's right. But what I have to remember is that all the stuff to do with opening ports, sending one reliable, sending one unreliable, byte string, we're going to find those things in a minute in the client implementation from the past. So let's have a look at that. The things I'm most interested in from the client implementation from the past is these connecting states here. So we've got, so in the future we've got connect, challenge, disconnect, disconnect. But in the past, what I had was a full system which uses the challenge messages, which is a way of making sure that the server and the client are sending messages to each other, and we make sure that they are both receiving each other's packets by sending what's called a challenge message. So first, when the client sends a message to the server, it sends a U32, the first message, and then the server sends back another U32. So they're both supposed to be random. So this challenge message that you see here is probably going to be declared just a bit further up or down. For those people who have just joined us, we've got a diff between the past, which is May, and the future, which is now, and I'm copying stuff over from my wise self in the past to my flawed self after I deleted all this cool logic that I created. I regret my decision, and so now I'm pulling stuff across. But unfortunately for us, I made some improvements in the process, so I want to keep the improvements, so I need to make sure that I pull stuff across carefully. Challenge message, where does this come from? Okay, so, oh, I just exited out of client. Let's go back into that. It's just a tuple as far as I remember, but we will find that really soon. I guarantee it. This AB, client AB, was probably because I was passing in a thread and they need to know about memory management. We got new connections. We returned a client. Oh, that's right. I think the client held the world state, and the world state held a specs object called dispatcher, and the specs object required an AB. It was a real nuisance, so I went away from that. I can't use dispatchers the way I was structuring things in the past, because I kept, if you wrap the world, it gets really painful to manage the dispatcher. So yeah, that's why there's an AB there. Okay, so when we create a new client, we pass in a connection and server address. In fact, that's how I'm managing the server address problem. I'm passing it into the client, and I'm keeping it as part of the client state. So in this case, we're not keeping the server address state. So what we're going to do is we're going to transfer that server address to the right into the future. This connection, I don't know if I want to put it in the client. Let's not do that. We're not going to put the lockstep client in there either. So we're just going to put the server address in. We've got a connecting state. Okay, a bit further down. So part of that means we now need to pass the server address into this constructor here, and we need to initialize it here. Okay, byte string. This was just a really easy way of sending things. We don't need that wrapper at the moment because of the way I've structured things. Process payload. Okay, so this is a nice debugging message back when I actually cared about those things, but now we just pass them into process message. Process packet. This is the challenge response code that I wanted from before. I wonder if process packet is still on the right hand side. Did I call anything process packet? I think I called it process incoming. So if we were to align this with that process incoming, match, handle events, match events. Okay, no. So, I see, process incoming is down here. Okay, so that's the one that's process incoming. So process packet was completely deleted at some point. I probably just went, yeah, we don't need that. So we'll put it all back. So that is inside of our client now. process incoming. So we've got ourselves. We no longer need to know the server address because that's part of our state, which is kind of nice. So I'll delete that as an argument. If you were here, Ardawan, you just joined us, but earlier we added that in, so we're just taking it back out again. When you create a client, you're going to have one server. You're not going to change the server while the client's alive, so it doesn't matter if it's stored as state. So we can leave that up there. Match connector. Try receive. That's already there. Oh, I need to change that from UDP receive to try receive, and I think this probably should be called R receiver, but I'm not going to put that right in right now. And then if it was a packet, I think we did something to check that it was that the client was fully connected. It'll be down here. So as the packet, we get the payload. We say what we received, and we call this thing called process packet. So here, yeah. So we'd ignore on the client. We'd ignore a connection because we were waiting for a challenge. I'm sorry you lost some of the stream there, other one. It's nice to have you back then, I guess. So in this version, we don't want to actually say connection OK just because we got a connection. We want to wait until we get enough messages to confirm that the server and client are robustly connected, which is going to happen through this process of receiving several packets. So we're going to call self process packet, and we're going to pass it this packet, and it's going to do magic things. So we don't want those lines that I just selected on this side, because they're all going to happen inside process packet, and I'm using Python comments. Nice one, Tom. That's my name, by the way. Okay. Brief interlude to think. Why do I do that? I don't know. Okay, timer, lost connection, other message type. Okay. So I think that's probably enough to manage to bring across what I wanted from process incoming. The most important part of the logic for the client is going to be this thing we covered here called process packet that understands when we receive a challenge, we're supposed to create a salt of our own, and then we're supposed to send it back with a challenge. And so this logic is what is going to keep the connection like validated so that people can't spoof each other. So that was the most important thing to copy from the client. We're going to get it all up and running though again, which is going to be interesting, to say the least. Just because it's been so long since I've thought about this stuff, and I don't want to break all the stuff I've written since. Send outgoing. Let's have a look at how that's different. So again, the left-hand side is the ancient past where we last used this library, and the right is the future, and everything we copy across to the right we're going to be modifying soon. So when we go to send outgoing code, we need to think to ourselves, are we currently connected? If we're connected, then we are going to, well, actually, back then, I didn't have any. Once the connection was done, we just sat there and did nothing. So the whole idea of actually having a network connection was new in the ancient past. But now in the future past's future, we have that, but we want to get all this validation code back. So So this outer if statement is actually irrelevant now because that whole thing was something Cobalt specific. And then we're going to match the connecting state. And so send outgoing, what's currently in the center here, what's currently in the center here, I don't know what this is, what's going on down here. I'm just going to remove this because I must have, wow. Yeah, no, I don't remember why that's there. That's interesting. Probably based on what it's deleted, right? If I undelete that code. If we have a connection, we're going to try and send data, and then we're going to keep trying to reconnect. Where I wrote that code to try and reconnect is really suspect. It's like, what the hell am I doing there? I do not know why that's there. Okay. Let's not worry too much about that right now. So here is our, oh, I'm trying to find my cursor, white cursor on a white background. Okay, there we go. So here is our code that's going to send out the challenge responses from the client. If it turns out that the client is ready to is fully connected, we're going to put in this code from the future, which actually sends useful messages too. And so are connected. Let's send something. Great. Okay. Do tick. So in the past I had this idea of a catch-up frame, which is something that only the ticker handles, but it, like, when it's going super fast, it sets this catch-up frame thing, which is kind of cool. And based on whether it's a catch-up frame or not, we used to skip sending and receiving messages, which is, you know, to try and catch up faster. Let's not try and bring that back. See, we used to implement tickable for client, which is why it had a do tick. And since we want to implement tickable again, we probably need to implement do tick again. Just comparing these two visually. See, on the right hand side we pass a sector in. So we're going to have to do this, and we're going to modify tickable so it takes a sector. We have to create a lambda. How am I going to manage that problem? I'm not sure. Okay, I'm not going to implement tickable for client right now. I'm going to leave this do tick function as is. Okay. Okay, great. What's the packet data you send and receive to detect the fully connected connection? Okay. What I'd like to refer you to here is called Gaffron Games. And let's just see if I can find the blog article I got this from. Client server connection. And so here it discusses how that could work. And it talks about how the naive protocol is naive, and then he describes what's called a challenge and a challenge response, and that means that from then on you have to actually put the challenge response in every message from then on. So this entire blog article sets out exactly what you have to do in order to ensure that it's hard. That one there, ensure that it's hard. So I'll just pop that also in the game dev while I'm at it, in the game dev folder in here. So if you want to go and have a look at challenge response, that's where you'll find it. Yay. Okay. Send outgoing. Must find my inner peace. I am now ready to proceed with coding. Let us begin. Send outgoing. I'm not sure why this isn't fully aligned. Oh yes, it has moved down here because we put this I mean, obviously, this stuff here, that should be aligned with this. That looks better. Okay. And so the future's only difference is now that it has this sending message. And I've duplicated it down here. I don't need that. Okay, so that client, I've now, you're welcome, Ardawan. I'm not sure how to pronounce it. Ardwani? Ardwani? I'm not sure how to pronounce that name. I'm very sorry if I just slaughtered it a bunch of times in a row. You are most welcome, sir. Client is done for now. I mean, it's going to be broken, but the main point was to bring across whatever useful things I could. Let's have a look at server. Server isn't too different. Got a lot of modules here. Got my challenge messages again. I've got this thing called client ID, which was provided to me by Coldwell, but we're going to kill that because I might need a client ID at some point in the future. Oh well. How about what I do is we copy left and right. So I'll just move these, copy these, and then do this, and then I'll put these underneath it as a reminder that that's what we're just taking out. Okay, client details. Server doesn't need that. Connection UDP wrapper doesn't need those. The client lookup is by socket address. Whoops. Yeah, so we just need to copy the socket address across to here. Server doesn't need to take a connection, doesn't have a sector in it, doesn't own a sector. Process payload, we're going to ignore this one for now. Process packet. This process packet contains all the logic that I needed to handle the challenge. At least, like, you got to understand that when I wrote this, I just kind of hacked it up. I didn't bother to make it elegant. Though it's not too bad, really. It's quite a lot more complicated than our existing process incoming. Let's do a quick comparison between process packet from the past and process incoming from the future. Okay. So, client state first message. Okay, so process incoming is supposed to split up the packets and then call process packet. So that's what we used to do. So we need to copy process incoming and compare that. So process incoming compared to this one. Wow. It's a very different approach. It's probably down to how much I've changed in my Rust coding. This loop and try receive is a bit less elegant than using while let OK equal event. It's like the different unpacking is just that little bit better. And then I had a match loop on the outside here. If it's a packet, then we call process packet. Whereas down here, if it's a packet, connect packet, we call handle messages. So what we need to do is call process packet here with the packet. So we're not going to unpack the packet, we're just going to leave it all bundled up. God, I'm going deep down the rabbit hole with this one, aren't I? So we're processing the packet. We don't need this. This code is going to go into process packet in a second. So we're going to go back up to here. Here's this process packet command from the past. We're just going to pull the whole lot across. And then we're going to go into, where are we? Connected. I'm just trying to find the state where it's connected and it's received a message. So this one here seems to be where it's got a challenge response and it needs to send back an OK, you're connected message. Here's where it detects that it didn't work. Yeah, this looks like that's when a connection starts. If it's the first connection attempt, valid response of challenge. Okay, so this here, process payload, that process payload is where we've got the challenge response. The first part of the packet is valid. It contains a header that says this is a valid other client, and now we can proceed. Okay. This is a lot of work. Makes me regret changing anything. Why even go down this rabbit hole? So here's the process payload. I don't think I have a process payload on the right side. So if you're new here, I'm just trying to recall my old logic that I used to have when I last used a library called Laminar. When I switched to Cobalt, I deleted this logic because it was no longer necessary, because one thing which is nice about Cobalt is it internally did this as part of its protocol, whereas Laminar doesn't have this protection. This is not okay. This is not exactly an IDE. What's going on here is I have committed. I've checked out using Git my repository in 2 different folders, and in the 2 different folders I've checked it out to different revisions, and then I've used a really great diff tool called Beyond Compare. So what you're looking at is just Beyond Compare, and then the 2 sides are those 2 repositories. So when I save on the right hand side, I'm saving to my new repository. That's where I'm currently coding. So that's what's going on with these files, and it's nothing special to do with an IDE. It's just straight up to do with and this is a trick I use quite often. To be able to like merge across or bring things across that are old or new, but this is a particularly involved example. I haven't done something this involved for a while. So F7 and F7 to this, and I'll align the 2, and so we can see that. Did I just copy that across? Because I must have just copied that across and then forgotten. Yep, I did. Okay, and the thing I was going to put in there was going to be the old. See, for the longest time now, I've been holding on my clipboard this a piece of code. Here's all the changes we've pulled across so far, right? These are all the things we've done. I've been holding in my buffer these 3 lines. Let me just put this into a diff tool so I've got a nice clean version rather than the one with the diff in it. So I just need to copy these 3 lines and restore them, and the place I need to restore them to whoops, is up here in process payload. Server process message. Okay. So in this in this version I have my own packing. It's pretty cool. I have my own packing of the messages that condensed everything down. It was another feature that was really nice about Cobalt, was that it does the packing for you. God, am I going too far down the rabbit hole with this one? But anyway, let's not worry about the packing right this second. Oh, I think I didn't take the packing out. Yeah, so I think there's no point where I stopped using the packing. That's good. Okay, so we've got to the point where we've received the base level of how this code works, which is that it calls handle messages. So if I have lots of actions to send at once, I deliberately concatenate them into one long bunch, and I send them all in one block. And I wasn't sure in my own mind whether this code existed. I knew it existed a while ago. I wasn't sure if it still existed in the now version, so whether I had to restore it or whether it was already there. I don't have to restore it because I never deleted it, so that's good. because I believe it's a. I don't want to send lots of little itty bitty UDP packets with tiny actions. I want to send some nice, decent sized ones. Still less than 100 bytes, but they contain lots of messages in them. And the way I do that is by concatenating tons of stuff I want to say at once, which is what this handle messages does. If we just quickly look at it again, handle messages uses a send a decode packet. That's one of my functions to decode this buffer, and it spits out tons of messages in a message list. I decided to just stick them in the vector of messages as opposed to use some sort of iterator. One thing that I miss in Rust that's cool in Python is being able to make a generator really easily, which is like a function that returns things one at a time. It's kind of like an opposite version of a sync. So you can return a value and then return another value when you asked for it, and you can even make an infinite list out of a function, but it also reduces the amount of allocations or whatever. It's a really elegant pattern, and you can do it in Rust with an iterator and stuff, but in Python it's really easy to make one. There are a few ugly wrappers, and there's some interesting ideas being merged in eventually, but they're not there yet. Oh, that was quite the aside. Okay, so this code you see on the left was how I used to do it. These are my different packets. And those are all handled now inside of sector. So this code you see highlighted on your left is actually inside of process message now anyway. So that's good. Connection okay and lost connection are just wrappers for state. We'll put those, whoops, there's no reason to put stuff into the past. Process incoming. Lots of stuff in here. Okay, so one thing that's different between the left and the right is because a little while ago today I was just saying that if you're a client and you receive a message from somebody else who's not the server, you probably should worry about that. And so I've added some code in here to worry about that. What I need to do is I need to put this code from the past into the middle of these if branches that have confirmed that it's the correct one. So if we receive a packet, let us grab the receiving of this packet, which is this code here, and let's look over here for packet, which is this code here, and I'm going to put in the new version of that, which is this. Well, the new old version. The old is new, etc. Probably don't need to worry too much about indenting. I probably can fix it more easily. I can't push tab to indent and beyond compare. It's tabbing too far. Okay, so process incoming. Okay, packet goes across there. Timeout. Client timed out. Let's leave that alone. Connect doesn't do anything useful. So in fact, processing coming from the past is almost useless. But the most important thing we've got is we've just got this easy wrapper here. Most of what I'm looking at on the right hand side wasn't actually necessary, because all it's really doing is this debugging code. So the only thing that was new was debugging code that I deleted in the past. I no longer need to see the raw messages going across the wire, but if I did, that would be how I'd do it. So this is just an implementation of message debugging, so I can see exactly what the client is receiving if I need to see the raw bytes. So we'll put that in and we'll comment it out. Well, we'll put it in for now, and then it might be useful later. If we're connected, that's when we send things. If we're tickable, good things happen. Okay, I think we're almost done with our comparison against the past, stealing treasures from the past to enrich in the future. Let's just see if we got anything else here. No. Okay. Well, I guess you guys have probably enjoyed staring at a white IDE for long enough. Let's go back to this lovely, cool, soothing. Here's all the things we stole from the past. Let's just quickly make a treasures from the past commit. Treasures from the past. I want to stage a commit all changes. Done. So I really love having having a commit dialog that shows no changes. While we're here, let's have a quick look at the Cobalt module. This is a submodule, and so it's my my IDE has gone and mucked around with what's there. I didn't think I'd made any differences. The Git GUI is called Git extensions. So you install Git and then you install Git extensions. I really like it because it burns my eyes. I agree, it is too white. I really like it because it actually supports all the Git features, and there are some amazing Git features that other ones hide. I don't want this IDE changes. We remove those. Okay, great. So this 0 here makes me feel good, and it makes me feel like so it's really interesting that it's because we're still in the submodule. Okay. So I'm just going to quickly make a branch here, create a new branch here. Feature player input. There's a new branch on that commit. This is a commit we're not working on right now. That's a commit that I shelved when I started doing this refactor. And then I'm going to create another branch on the current commit, checkout. Well, actually, we'll leave this one on master. So, we're pushing player input feature to my GitLab remote. Yes. So it's just going to quickly push that across. This is blocking, so I need to wait for it. Okay. And then we're going to just check out again this one. Check out. Okay. This is checking out all the libraries as well. And we're going to create a new branch here. And this one we'll call feature, it's called Network Laminar, I called it. Okay. And we're going to push that as well. Push. Yes. Get a trapping reference. Because that basically means it shows a little green thing saying GitLab master. That's what the tracking reference is. Okay. So all my work is backed up. So if at this point my computer lost its hard drive, and I hope it won't, I'm not going to lose anything. So that's always a good state to be in. Okay. Let's reorganize everything. So what we're going to have is I've got a lot of different editors open. This one here, let's just have a look at the path that comes up here. Copy path. I'm just confirming on the other monitor that this is indeed the modern source code. So we're not going to run into any issues where I'm editing the wrong source. Before I try and compile, yeah, I find it navigating. Adwani complains that GUIs suck. There are advantages of working in console. I agree, and it kind of is a bit try hardcore, but I find I get a bit of visibility across the log and what the hell's going on, and it makes a lot more sense across branches. And the difficult Git problems are a lot easier to solve with a UI. I find I work for some time with limited tools, and I find that the console, I can do everything in the console I want to by myself. If everything's really simple. When it gets hard, it gets a lot harder. This is asking me to add those workspace files back, and I just deleted it. Oh well. It's going to be fine, Tom. It's going to be fine. Okay. We're going to do a quick review for sanity to see what is going on. We've done a bunch of merging. There's going to be a whole bunch of weird code in here. Lots of red text. Take forever. Import. Where does Tick Forever come from? Oh, yes. Okay. Wow. This is an iterator I created some time ago. Simulation source lockstep. Man, past me is so cool. I came up with some good stuff. I love it when I find an old piece of treasure that I'd forgotten I'd written and how I'd written it. It's an iterator that just pauses whoever calls it until the right time. I mean, you know, neat. Weird Constructor says he's the same as Adwani. So Vim and console, even on Windows, but for browsing the history of the repository, things like tortoise.svn or GUIs that make branches more visual and stuff like. Yeah, so I use git GUI from the console that did that. As fast as I'm using terminal, not an issue though. Yeah. Yeah, I'm not worried about using the terminal. I mean, when I was working in Linux, I was using the terminal quite a lot. But you know, I just find I can see more. I mean, you look at the 3 monitors here, and I've got a lot of stuff going on. And I know you can split screens in part with terminals and so on. Hey, I've got nothing to prove to anyone. I'm happy with this. The speed at the moment is not a problem with keyboards or inputs. The problem with speed is because of my approach at the moment. I'm still figuring stuff out. Okay. Yeah, I find figuring out which files to add though, I'm more selective than that. I usually check every single diff and go through all the lines and actually manage my patches very carefully. And doing that with Git Add Interactive is a little bit slower than doing it with the user interface I use. I find it's still possible, it's just slightly slower to do it via the console. Run server. Okay. Process incoming, receiver and sender, server, receiver. Okay, so why is that red? Okay, so it's modifying receiver. Why do we need to modify it? We should be able to take copies of that. So why am I passing in a reference to it? Because the receiver doesn't need a reference. As far as I understand it, it's basically a small object for crossbeam. You're supposed to just duplicate it, because the receiver T just contains a flavor. I can't remember if you're supposed to pass them by reference or not, and I think you can treat them as const. Let's not copy it, let's just pass a reference. So we'll just pass a I'm just going to bring up the crossbeam documentation real quick. So we're looking for the struct called receive. The question I'm trying to ask myself is receive dead takes a non-mutable reference, so it doesn't require me to pass it around as mutable because it's designed to be treated as immutable. Essentially, it's like atomics. You can modify the. Okay, so we don't need to copy this server. So I'm just going to put create a server and client. We're going to close everything on the right, and then we've got lib. I'm going to close others. Oops, that was not what I wanted to happen, but oh well. We'll try it again. Split. We don't need. We want server. Come on, drag. Yay for GUIs. I'm sure you guys are like, oh my god, this should be easier. Yeah, it should. Okay, run server. I blame you guys for the giant font size though. That's all your fault. That's all I'm saying. Run server. Process incoming. Got a receiver. Doesn't need to be mutable. Don't need to pass it as mutable here. Don't need to pass that as mutable. Send outgoing. Doesn't need to be mutable. Sender hasn't been imported. We're importing it from crossbeam. Over here, those don't need to be mutable. We don't want to pass something called UDP. We want to pass something called receive and send. So we've called them sender and receiver here, so we'll call them the full names down here for the client too. Receiver, sender. We pass in a sector. Yes, we do. It needs to be mute. That's correct. What is this? It takes 2 parameters, but 3 parameters were provided. That's because the client now remembers the server's address. So when we create the client, we need to pass this in. So client new passes in a client, it's the server, and then this client will remember the server address, which is nicer. So those don't need to pass it in here. This probably still takes the mutable. Yes. Okay. This local, this whole thing. I used to import an entire file of time library just so I could print this lovely string showing the time, all beautifully formatted. I can't be bothered. I don't like the idea because it was like a module that imported a module that imported a module, and it's just so expensive. It's not worth the trouble. So this tick, or this wait, is going to be required now that so this, you see down here, this loop, I'm going to need to use a similar wait trick. So what I'm going to do is, instead of using the tick thread, I'm going to move this wait. So remember the tick forever I showed you earlier was this little class I created. It's an iterator that deliberately sleeps, halting the thread to keep the tick rate consistent. So by looping over that code, it's going to force the server to run at a certain tick rate like this. Now we were relying on Cobalt to do this for us, but now that we're not using Cobalt, we need this back. So I will put this up here, and we don't need to send outgoing messages, and then we'll just say auto delay forever, and that will just keep going until I cancel it by Control C, and we can achieve a very similar thing down here. One thing to bear in mind is that this do tick for the client will deliberately do catch-up ticks, where it ticks to 100 times per tick in order to catch up with the server. Later on, I'll have a nicer way of catching up, which is going to bring it up to the server at a nice gradual pace. But for now, it's very aggressive. You still loop until client live, which is atomic variable, would go false, which would tell the client it needs to quit. I'm going to put that inside like so. If not, wait, wrong, not Python. If that, then we need to break. Gracefully. So it's like gracefully, but spelled incorrectly. Okay. Nice comment. That's the server and client. That's the outer lib done. So look through client. Server address. Our state. So there's some interesting indentation going on here because of the diffing. I might just move this. I generally try and work on this side. So we're working on client. Our state starts off in the connect state. It needs the U32. What did I use to generate a U32? I think I just, for testing purposes, and I totally won't leave this in until the game is released, because that'd be so wrong. I probably just hard coded one in. Let's have a look. Our state, connecting state. Interesting. I was expecting to see, yes. Here we are. That makes no sense. Oh, that's a type. For new, I'd set it to 100. Yeah, I just put a constant in there. I just want to see if I put something random in. Because what I should be doing is I should be sending a random number. The client should choose a random number that's going to send the server, and so that way, the only way the server could know what number to send back is to have a look at what the client sent it. That's why it's random. Whereas if I hard code it like this and the server already knows the numbers, so that means you can send spoof packets to trick clients into thinking that you've received packets from them. And because in UDP that's possible to do, you could hijack a connection pretending to be from the server. Which is why it needs to be random. See the link further up in the chat to Gaffron Games if you want to know more about what I'll be doing here with the challenges. Okay. Our state is going to be connect. And that reminds me when you go to the server probably also needs a state, client state. And so whenever a new challenge, I'll need to import the socket address client state. Whenever a new client is added, it's going to have to do the same thing. Do we have add client? How do we add clients? Yes, did we get one? Oh yeah, it'll be in that big pile of code that's process packet. See, there we go. So we'll try to get it. Here we are inserting it. And in this mess will be probably a hard-coded one for the server. It's probably this 5678 here. Yeah, so there we are. I gave you away all my secrets. Haha. I'm going to have to put random numbers in there. That's basically secret generation type stuff. So, in order to be secure, the game needs to randomly create those numbers and in a way that I can't tell you how it works. Or I can't tell you the key that generates it or something along those lines. Or how I set the random number generator or some other similar magic. I'll have to hide that. But for now, it's just a constant because, the advantages of not releasing your game yet. There are a few. Okay, run server. So I'm just working my way down from the top to the bottom of this client file, looking at the problems that I created by importing the past into the future. So I had an old approach, and I'm bringing it back, and so it's caused a number of weird things to happen. How do we do connection okay in the past? That's an interesting question. So if I was coding without you guys, I would have this diff that you can see here. I'd have it open all the time on my right hand side, so you probably can see now that it's on the right hand monitor. You have a look, and then I'll just have, oh my god, that's so bright. Can you see how bright it is on my face? It burns my eyes. Anyway, and I'll be coding like this, but I'll just put it for your benefit. I'm going to put it over here, so I'm getting less because of you. It's a burden, the burden of streaming. Don't worry, I don't resent you. Anyway, so I pop it over here, and I want to see what happens when we go to connected, because I must connection OK. I wonder if I even have a connection OK function. Probably don't have that in the left, no, in the past. What if I still have it in the future? Oh, I'm looking at the wrong diff, that's why I'm not finding the thing I'm looking for. Oh, I should have said yes. Where am I? Yeah, connection OK and lost connection are only in the future. And I think we'll probably find they're not being used anymore either. So this function has probably got no references. No, if I push F3 on that, it doesn't find it. In timeout we call lost connection. What are the connecting states? Okay. In disconnect we remember our challenge message. So where do we set disconnect? Okay, so I never actually set the client as disconnected in my original code. But that's not really very good. So we'll just add some code for that. So lost connection. So we put it. We do this. So if self.our state and is and we're going to use let. We're going to do some unwrapping, and we're going to unwrap into connected. So if it was connected and it had challenge was equal to self.our state, then and we need to use connected state here. Oops. So if it was connected, why is that being said? Oh, I've only put a single colon. Okay. We unwrap a challenge. Or if it's connecting, if it's in the challenge state. So if it's in one of those two states, we're going to unwrap, and by unwrapping we get access to the internal variable called challenge. So it's moved it out of self.our states. Bring a complaint, you can't move. Yeah. What if I can do it this way? Self.our state equals if that, it's going to be disconnected. And it's going to be the challenge. Else self.our state. Yeah, we'll do it by reference. Okay, so if it's this, if you have that stuff. This is a really good point. Thanks for Delaney. Okay, we're working on lost connection. This is where we are. Thanks for reminding me. So lost connection, if it's connected or challenge, we're unwrapping to get this variable challenge, but it's complaining that we cannot move, so we need to use a reference, and then challenge is a reference, so we need to dereference it, and or copy it. It may complain here, cannot move. It's okay. We'll clone it. So if we're connected or in challenge, we're going to copy this challenge variable from the middle, which is just a challenge message, which contains this, both the salt of the client and the challenge salt. So these two different two variables. So if it's in one of those states, connected or challenge, it's going to copy that back into one which is disconnect. So that's what lost connection looks like now. Our state is connected. We don't need to keep connection, okay, because that logic is handled. Process packet. Deserialize message packet payload. So I need to grab that. Deserialize. It's in this module called bin code that we're using to encode and decode structures. I'm getting a lot of people watching. Is my Reddit blowing up or something? Just gonna quick look. Sorry guys, just a second. Posts. Great, 5 upvotes. I'm glad you guys voted. Thank you very much for my Reddit post. Oh, now it's down to 3. Oh well, it was nice you guys all voted when I mentioned it. No, it's just Reddit being rude to me. Anyway, still nice. People care. Cool. Thanks for joining me. I really appreciate it. I've got a lot of articles on Medium about what I'm actually up to. Let me just pimp those real quick. I'll be right back to it in just a second. I'm just like rendering a 2D game in 3D. So what you're watching is the network code, which is behind this computer game here. So if you want a bit of a history lesson as to what the game's been about in the past, jump across to Medium. There's all sorts of things on there. I hope you have fun. And that has been your brief pimpin' overview. There's a Twitter and a Discord there as well. Feel free to jump across and have a look. where were we? Messages. Okay, so the messages have these other ones on the front. Connect, challenge, server state, spare one, action process and action submit. They must also still be there because I don't seem to have removed them. I think I just left them in. Because these first ones are critical in order to do the process I'm doing at the moment, where it sends a challenge and a response as per the Gaffer article you'll find in the comments further up. Process packet. So we want to get the first message, and then based on our state and the first message, you see I form them into a tuple here, and then if our current state is we're trying to connect, and the message is a challenge, then we're going to process it here. If we're in the challenge and the message is a challenge accept, so these are the steps we're trying to go through here with our challenge process. So first, our first message says basically hello or connect. It has a secret number that only the client knows. Once the server knows, it's going to send the number back to the client, but it's going to add a second number, which is a server secret, back to the client. And now the client knows both numbers. But somebody else, so if somebody else is sitting elsewhere and they can't see these packets going back and forth between the server and the client, if they're not snooping the packets, they won't know the numbers. If they're snooping the packets, they'll know the numbers. But what it means is if someone sends a random packet to the client and it doesn't have those two numbers in it, the client's like, I don't think you're the server, because the server knows these two secret numbers and you probably don't. So I'm going to ignore you if you don't have those. So that is what this process is supposed to do. And actually on the client, we need to add some code here. And I might just put a quick to-do. Need to keep checking for the server's fix. The server just sends the prefix on every message it sends us. Is that checking constantly in the main loop? I'm just trying to figure out how to explain this to you. Okay, so in lib, we mentioned this earlier, we run this routine called run client, and run client is usually called inside a thread. So if we look at where run client is called from, it's literally just created a new thread just for the client, and then it goes into this infinite loop, and in that loop it calls this process incoming, which passes in all the network packets that have been received, and we're looking at the code inside of process incoming basically right now. And once it's done that loop, it then pauses for a while, and so the game is actually in a different thread. So this isn't actually the main loop. However, what I'm planning to do is to actually call this, so later on, once this is all working, I'm going to do another refactor. We're going to stop using this thread, and we're going to call these three functions from inside of a go.dot routine. So go.dot, well, at least for in the client in the game, go.dot is going to call a fixed tick rate function, and that's going to kind of process this. And so by doing that, I know that the go.dot thread, when it's running, it essentially owns my game data. Whereas right now my game data could be hijacked by the network thread at any time, because the network thread is sitting here constantly waking up and trying to process this data. And by allowing Godot to manage all that, it's going to make my life a lot simpler. I won't have to worry about mutexes. I won't have to worry about inter-thread communications of my game state, which is something that's been bothering me a lot in terms of my design. So what you're seeing is me simplifying in a very complicated and convoluted way, while trying to look at a lot of different code from new and old stuff that I haven't managed for a while. And the idea of the stuff is it's supposed to kind of be magic. Like I haven't had to touch it since I wrote it, because the stuff I touch is like it's higher level, and this is like the low level grunge that like holds everything together. I hope that was a sufficiently complicated explanation to bamboozle you. I mean, to enlighten you. Process payload. I'm just reading the next question from Adwani. Is the thread constantly checking the connection? Well, what's strictly going on is actually the library I'm using is checking the connection on a different thread or some other way, and it's putting the messages into a crossbeam communication queue, and we're popping them off in a different thread. So in our client thread, we're actually popping them off. Messages that are being put there by Laminar. Laminar, I believe, is running an event loop that's actually doing both send and send at the same time in a very efficient way, and is not worrying about my frame counter at all. And so it's just transmitting and receiving binary data, and so it makes a lot of sense for us to move our threading to that binary data and away from the game data. So that's why I'm making this change. If that made any sense. If not, I suggest you read the docs for Laminar, and you probably know more about it than I do pretty quickly, because I've forgotten everything I learned. I just learned enough to be comfortable with my decision making and move on. Process payload. Need to keep checking for the service prefix. Yes, we do. We don't seem to have a process payload function in the client, which is really suspicious because I thought I brought it across. If I search for process payload, I can't find it. I thought I had brought that back. In client, and yes, we want to reload, and process payload. Yeah, there's it being called. Oh, it's called process incoming, I think. Now. Okay, it used to be called process payload. Interesting. I don't get this. It's not making sense. So here's the process payload that it was just claiming it couldn't find. Now we call it handle messages. Process payload takes the packet. Handle messages takes a message buffer. Process payload doesn't have a sector. Okay, so I've basically taken process payload and I've renamed it handle messages, and then I've added this idea of a sector on the end. And otherwise it's very similar. So I just need to go back into my code, and where it says that it wants to call process payload, it actually wants to call handle messages. And this sector is actually one of the arguments that we pass in here. Or not. I'm going to lift this up to the next level. So sector is my game state, basically. Process packet. It's got a sector. So we'll just process the sector, like so. Okay, so that's happy now. Any other frowny, facey red things? There's a red line here on the side that tells me that something's not happy here. Handle messages not happy with packet. There's a message buffer with a vector of U8s. Oh. Okay, so that's an unwrapped packet. That's what the packet looks like once it's been. I've sucked all the juices out of it. We'll go back to the diff tool. Yes. Let's have a look at how we process the payload. We use this messages send a decode packet.payload. Oh, there's a function you can call .payload. I never noticed that before. Interesting. And then it creates a list of messages. So let's see what packet.payload does, because I must have called it for a good reason. This is my blog article, by the way. This is what it looks like when it's working. So we're going to go to Laminar. So let's just duplicate this tab because I like to have one open for each library, and then we can go to find crate, type in Laminar up here. Okay. Laminar, that's the one I want. And the question I was asking is, what is a packet? So it's not, what is love? No, not that. Anyway, packet. Okay, so payload returns a pointer to the buffer, and by returning a pointer to the buffer vector, you can actually cast that trait to a vector automatically. So handy dot payload. So handle messages. Expected a vector found. No. No, it doesn't work. Okay, how do we make a vector from a slice? I bet there's a function called from slice. Oh, that's right, last time I tried to do this, it was a real pain in the ass. I had to grow it. I bet I could go from. Let's just try into and see if it works. Why didn't I think of that last time I was doing that? So there must be from implemented in here. If I have a look, I bet there's a from implementation at the bottom for that. Why am I still doing this? I don't know. From. Yes, there's one there. This lovely implementation here. So if there's a from, oh, he's called toVec on it. So slices know how to turn this into vecs. And that's why when I type into, so maybe instead rather than saying into, I'll specifically say toVec, and then it'll be nicer anyway. But that's how it works. So if you guys ever want to like cast your types to other types, you create a from implementation. It's very nice. Okay. I can't see any red lines along the side of my bar here, so I think that as far as C-line is concerned, these files are happy. So let's ask the compiler, oh compiler, what do you think? And it's going to tell me, no, you have sinned. How much sin? Quite a lot of sin. It just goes on and on. But don't worry, friends. We shall address this one part at a time. Okay, so UDP wrapper to byte string, use of undeclared type UDP wrapper. And C-line doesn't know what to do with it, so it doesn't even show it as red. I don't think I have a UDP wrapper anymore. But that would have been a useful library that I would have written at some point or another. And so if I just quickly, we're in the client, so if I just go back into my div tool and I go back into the client, we'll get a clue, yes, as to where that came from. I think it's probably one of my own functions. Yeah, it's just here is a UDP wrapper. Oh, that's right. It was that class that I mentioned early on that I wasn't going to pull across. You know, that one that would have been so useful and made our lives so much easier or something. Compare contents, compare to lib. I probably need to call it in about 15 minutes. Hello, time to go to bed. So just a warning in case you guys need to start preparing to start doing something. And I've mentioned my Medium articles and so on here. If you just jump across to there and go to Discord and hang out, I'll tell you when I next stream, or maybe I'll pop it and read it again. I really appreciate you dropping by. And you can find me under Tom Lees on YouTube as well. I'll probably put this up there later. Okay. Let's continue for the next little few minutes. And I've completely forgotten what I was doing. I was looking for UDP wrapper, wasn't I? UDP wrapper. It's not in here. Okay. Main, client, connection. It's in here. UDP wrapper. So it was byte string. So it's just this mouthful here. So given, oh, okay. So byte string was just a really nice little handy utility function that created a hex dump of whatever buffer I passed in. It doesn't even require self, so it's just like a handy dandy utility. So maybe we'll just throw it in my simulation code just for usefulness. Did I put a util in here? We'll put it in the network code. So let's go into network.rs and we'll just throw this useful little function in here. So given a slice of U8s, we're going to iterate over them. We're going to map every one of them to a string of 2 hex bytes. We're going to click those together. We're going to join them with spaces. So it's basically a hex dump. Nice little trick there. So when it says here raw byte string, so I need to make sure that my network code, this is public, and then I'm pretty sure that network is public in lib. Yep. So what that means is back in this code, it should actually figure it out, but it's probably too much has changed at once. But I can import it here. That's the one I wanted. I really like how in Rust you can use these curly braces for your imports to like make them more concise. Okay. Cannot find Cobalt Con in this space. Okay, I don't get it. I've changed too much and now the line numbers don't match up, so we're just going to ask the compiler to help us a second time. Okay. So we no longer need to prefix that with a UDP wrapper. Cannot find Cobalt Con. Lost connection. We don't need to keep track of the connection that we lost, I don't think. This is a client? Yeah. We don't need a con here either. Okay. Don't need that. Cannot find server address. Server address is in self. I think I called it SVR address. No, I called it server address. Packet. The packet's been unpacked already. We want payload. Message. Okay. I think again we want payload. I think we called it message buffer here, as opposed to payload. Yeah. I think if I put a reference to it, it'll figure itself out. Yep, that seems to have worked. Let's just get a fresh list of errors. So I'm just refactoring by changing networking libraries between Cobalt, which is now hasn't been maintained for 3 years, except for a few things I changed, to Laminar, which both of which are UDP libraries. And what I've done is I've brought code across from May of this year that I wrote in the past for Laminar before I changed to Cobalt. Probably a mistake. And I'm just bringing a lot of that code back across and fixing the bugs. Part of the reason why is I've decided that I like the threading model of Laminar better as well. And it's going to facilitate a later refactor, which will simplify my game loop. Server address. If the ID is equal to the server address. Not found in... Oh, that's right. So that's self-dot. So I think that's probably enough times looking for server address. So we're going to go is vr addr control H, put in search and replace all, and we're going to do the same thing in server. Is this the same server file? Yeah, it's in the right place. Okay, do the same. Okay, that doesn't have that problem. Yeah, well, you probably haven't heard of Cobalt because no one's maintained it for 3 years. Okay. Payload. Laminar is also the UDP networking library, which has been chosen by Amethyst, which is the collection of libraries for the Rust gaming. So, one more reason to use it. I mean, I'd be using Amethyst myself if it was mature enough. But I really like the Godot editor, so I'm just basically stealing all the good stuff from it. And then contributing a bit when I can. So process packet, payload, yes, because I called it message buffer. message, byte string, message. Again, it's called message buffer. Why is this not happy? Oh, it expected the raw packet. Okay. So, okay, so what we'll do is we'll unpack it a bit further down. So we need a packet here, so we'll pass this a reference to the packet, which is what this expects, I think. Or does it expect me to move the packet? I probably moved it. Yeah, I decided at the time that it was better to move it, and then it's more efficient. So for this code, I need to unpack it. So we'll grab this equals packet, and we don't want yeah. So what we'll do is this is debugging output. So I might even put curly braces around this to make it really obvious. So so we're going to, all this code here is to write a nice little string for debugging a packet. And of course now I'm starting to think that I probably should just put that in its own function. Yeah. Which then makes you wonder if I should just write a debug function for packet. Implement debug for packet. In fact, they probably have. Whatever. Print packet. So you'll see that it's just been moved down here. So, given a packet, we decode it here. And in fact, I should be able to do this here. And then, I don't think I need this. And that might work. If ID is the server address. Yeah, that was assuming that the packet was already decoded. Packet.id should work. Cannot find value payload in this scope. Again, packet.payload. Packet.id. Cannot find connection. Send all. So this UDP, we should probably call that send. Yeah. Now this send all utility function, send one unreliable. Well, we actually have already implemented send all because we've got in sender. I've got this. I've already told some of you guys, but just for those people who don't know, I've done that earlier in lib. I created a trait. No, in connection I created a trait called sender tools, and in sender tools I created a method called send all that would work for any sender. If I pass in a sender queue, which is basically a vector of messages, it would map them from my internal representation of messages and copy them across into the version expected by Laminar. So that's what's going on there. Run client, where was I? I was in server. Okay. And in server, well, no, where was I here? Connection. And I was thinking about the send all routine. And the send all routine isn't a problem. We'll just compile this again, and the top here will tell me what to do next. This one here. So this send all routine, we've got that. It's in sender. So, call that the full name sender. But we don't have a send one unreliable. It's complaining because I don't think I've got the trait imported. But by doing that, it's just brought the trait in. Why is that still complaining? Yeah, so it's complaining because my trait requires a mutable self, but it doesn't need to be mutable anymore. The reason why is because I can actually call send on the socket, the sender, because it's a multi-threaded type thing that allows you to write to a non-mutable one. It's very nice. It's a crossbeam. I can't remember what the name of the class is now. Anyway, it's written right there, sender. It's from Crossbeam, which is a library that allows you to do multi-threaded sending and receiving very nicely. I need to stop in somewhere 3 minutes. It's been a real pleasure working with you guys. Thanks for dropping by. Send outgoing. Let's see. I don't know for sure when I'm going to drop by and stream again, otherwise I'd tell you when it would be. But I can put it in Reddit and I'll put it in my Discord. Yeah. Once I figure out a schedule for this, I'll let you guys know. I've only started yesterday because of Weird Constructor told me to. I just do what I'm told, you know. Let's see. So I've got a function here called send one unreliable. Now if I go back into the past and I have a look at, man, I've got so many of these open now. Anyway, if we go back into the past and we'll just close some of these tabs. One of the things which is funny about Beyond Compare is it likes to show them as different windows in the you probably didn't see them. It was only something I could see on my other monitor. You can probably see them popping up here on the left hand side, but there's like lots of little windows showing up. Anyway, don't need those. What I wanted to do was have a look at I think it was in connection, and then we had these useful functions, send one reliable, send one unreliable, and what we can do is we can grab these and they create packets. And so what I'm going to do next with those functions is I'm going to bring them across and pop them in connection, and this trait that I showed you earlier, I'm going to put them in this trait so that whenever I have a sender, I've got these functions I can use. Send one reliable, send one unreliable. Okay, now these were originally written, I was kind of trying to be quite cool and reusable and so on. I templated anything that's serializable. You could create this client class with it, but I can't be bothered with that nowadays. I'm just going to use center Q for that. So I could use a trait, but it's overkill for me right now to manage template variables for when honestly I'm only going to ever use one type, so I just can't bother. So center Q sends instances of type message, and that's the type I'm going to send. So if we're sending a message, are we moving a message? I'm going to say sending isn't moving. Sending is just using a reference because we're going to serialize it anyway, so it's going to have to build up a buffer anyway, so it's not going to make a big difference to performance, and I shouldn't get too worried about it. So reference is nicer. It's like easier to work with. When you're implementing a trait, they don't need to be public. And then the way I use the word connect here, obviously I copied and pasted it before, so I should call that data. Data is serializing, and then I've got some print lines here. I probably don't want to keep those for very long, and then packet sender is sending, but we're not using packet sender really. We're going to use a sender queue. So no, we're not. We're going to use self. So self is a way of sending messages, and the way we send messages is we're going self.send. So like this. Now it's complaining because these are not in the trait, and what to do to fix that is put them in the trait, like so. This is the only place that this trait is implemented, so it's no, I don't do anything else other than that. But if there were multiple ways implementations of this trait, I'd have to go and put them in there too. So by doing this, whenever I have a class of sender packet and I've imported connection and this trait, I can now access these functions on it. So in this way I've created my own convenience functions for dealing with the sender, which make it a little bit easier to do this, and they do some extra debug output. I'm not sure if I want to keep that in or not. I just realised I'm at the bottom of the screen again. Sorry about that. Okay. I can't think of a good solution to the off the bottom of the screen problem. We'll have to just live with it for now. Other than probably the best thing I could do would be to make my editor smaller. Or the other way to do it would be to shrink the whole screen to a weird resolution, or stream it at non-standard resolution. I can't see that being good either. But there'll be something somewhere in there that makes that possible. Anyway, we'll leave it like that for now. Okay, so that should we're just going to check that that's fixed the last bugs, and we'll call it a night. Send one reliable. So we've got a lovely little chat channel, the Recall Singularity chat, and I'll just find the invite which I posted in here earlier. I'd love you guys to drop by. It's in the chat right near the top here. Let me just paste it one more time. So if you want to drop by and hang out with us and talk about game development, you'll be most welcome to. Please do. Send one reliable. So we should find that if I compile this now, the place that was calling it. Well, there's no bugs about that. So my list of bugs has gone down quite a lot. Well, compile issues, probably a better description. And it's probably pretty straightforward stuff, but it's getting late and I need to call it a night. So thank you so much for coming past, and it's time for me to hit that big red stop stream button. So good night, everyone.